welcome back to McClatchy Maths. My name is Natalie McClatchy and we are continuing our video series on how to write a problem-solving and modelling task with our 7th video from the Solve section of the Instrument Specific Marking Guide, the ISMG. It's a mouthful, isn't it? And our focus today is on coming up with a complete solution. Now, before we get into that, I just want to tell you a little bit more about how you can engage further with us here at McClatchy Maths. You could consider liking and subscribing and hitting that notifications bell so you'll always know when the next video is available to watch. You could follow us on Facebook and Instagram, or you could consider telling someone about this video. You could click that little arrow button to share the video with a friend or a family member, or you could put it on your Class 1 note if you're a teacher. And if you want to contribute a little bit to helping keep the channel going and contribute to helping with the costs of running the channel, you could consider saying thanks. There's a little hearts buttons where you can donate $2 to the channel. Let's get straight into the ISMG that we are focused on today. This is our Solve section and it's worth 6 to 7 marks out of the possible 20 marks of the assignment. We want to hit in that top range right there. So this is really the important part of the assignment. The most important part, it's the maths part. Okay, and we are focused today on a complete solution. Now, let's have a little bit of a look through the ISMG. If our solution's not complete, what is it? Well, yes, it's incomplete, but we can hit this one here, substantial progress towards a solution. We don't have a full solution, but we've made a good effort towards it. Okay, if we drop down to the next one, we don't have substantial. Substantial means a lot or of substance. But we've made some progress. We've got started. We've done a few things that are important. We just didn't quite finish. So that would hit us in that 2 to 3 out of 7 range there. And obviously, if we don't make any progress towards the solution, it would not match that descriptor above. So it would be in that 0 range. Obviously, it would also depend on what we've done in these two parts here. Okay, some things we want to consider. First of all, what does complete mean? Well, according to the Oxford Dictionary, it means having all the necessary and appropriate parts. So for the strand of mathematics that you're doing for this assignment, your teacher would have a list of all of the things that they've taught you, and they're all the things you're expected to demonstrate for the assignment. So that full list there, if it's not all done, it's not complete. It's not a complete solution. So then you wouldn't be hitting in the 6 to 7 range. Some other words that we could use for complete for those of us who like a good synonym are things like absolute. It's absolutely finished. It's thorough. It's finished. It's accomplished. It's finalized, and it's been fully concluded. Okay, so not part done, not 90% done. It's 100% there. Okay, in other words, you've done every mathematical procedure that was expected of you. Now, you may not have done it 100% accurately. That's okay, but you attempted everything. So this is some things we want to consider here. Accuracy. Now, we already considered accuracy when we were looking in video 5 on accurate use of mathematical knowledge for important aspects of the task. So if we didn't quite get things accurate, we've made a few errors along the way, we could still have a complete solution. One does not rule out the other. So that's something important to remember here as well. However, if we made so many mistakes, we've picked all the wrong graphs, we've done all the wrong techniques, we've done lots of things wrong, then perhaps our solution would not be a complete solution. So then we may not hit this one or this one. So that's very important that we're actually using the right mathematical knowledge in the right way. One kind of helps the other along. The next thing to consider is that this particular performance descriptor replaces, under the 2019 syllabus, the confusing one, discerning application of mathematical concepts and techniques. Now, basically, what we're saying with a complete solution is we've written it in student-friendly language. It makes sense to call something a complete solution. We know what that means. We know what complete means. We know what the solution is. Whereas this one here was always under a little bit of interpretation for our teachers. And also students found it hard to understand what this was. So this is a descriptor that is replacing that. A good thing to do when you're considering writing your assignment is look at the flowchart at the back of the assignment. Your teacher has created a formulate, solve, evaluate, communicate flowchart from the QCAA's problem-solving flowchart, and they've possibly put some little clues in there about what you're meant to be doing. Now, if you check what you've done against that checklist, then you can be certain that you've got a complete solution. Your teacher may also, as part of the scaffolding of your assignment, write another checklist, or they may have given you feedback on a draft. So So that's a good place for you to check and make sure you've done everything that was expected of you. So if your teacher expected a certain type of graph or a certain type of procedure and you didn't do it at draft stage, then your teacher will be able to tell you in that draft feedback that this bit was missing or that bit was missing, or that it's not a complete solution. So that's a very important stage of the assignment, is that draft feedback stage. I always tell my students, try to have your assignment finished at draft feedback stage so that you're getting the best possible information from your teacher about what needs to be fixed. Because if you have large sections missing, they can't give you any feedback on what's not there. Also consider going and have a look back through your course content. Look through the textbook chapters that your teacher's been doing with you in class. Look at the Class 1 notes, any PowerPoints your teacher's created. There's a lot of mathematical knowledge in there. Have you demonstrated all of it? Because if you've missed bits, then you probably haven't got a complete solution. So let's now look at substantial definition. Now you'll remember with our ISMG that if we don't have a complete solution, we're then expected to make substantial progress towards the solution. So what is meant by the word substantial? Well, the definition from the dictionary is a little bit vague concerning the essentials of something. Basically, it means have we done all the really important parts, the essential parts? We've made significant progress. It's considerable work that we've done. It's just not 100% of the way there. Now, I'm not going to put percentages around, is it 75% complete, is it 60% complete, is it 90% complete? No, that's your teacher's call, but my expectation would be is that most of it's there. It might just be one or two little important parts that are missing, but not significant parts. So this comes from the Oxford Dictionary. So you've done almost everything. You made a great deal of progress. There's a fair bit of substance to your assignment. That's where the word substantial comes from. It's got some teeth to it. It's got some meat in what you've done. It's just not all the way there. There's just something missing. Okay, so the next standard down is in that 2 to 3 range. We made some progress on the task, but there's too much missing for it to be called substantial. So let's talk in the context of IA1 for general maths. Typically would be a bivariate data assignment. So you'd be expected to create a scatter plot. You'd be expected to calculate and interpret R and R squared. You'd be expected to then go on and maybe make some predictions, some extrapolation or some interpolation with a linear model that you have developed potentially algebraically. Your teacher may be happy for you to do it with technology, or you may have to use the formulas for A and B to develop that. And then the last step of that is to create your residual plot. Now let's say you got all the way there, but you missed the residual plot. In my mind, that would be you've made substantial progress. But let's say you just started with a scatter plot, and maybe you talked about the correlation and that's all you've done. There is way too much missing for you to have been able to make substantial progress. You've made some progress, but not enough. Well, that's all we have time for today. I hope you found this video helpful. If you've got any questions about anything you heard or saw on the video today, you can contact me at mcclutchymaths@yahoo.com. Well, I'm Natalie McClutchy. Have an amazing day.